Hi, this is Alex from devstories.eu. Alembic Database Migrations, Episode 5 of 8. In highly regulated enterprise environments, developers almost never get direct access to run Python against production databases. When deployment day arrives, database administrators will usually lock you out and demand a raw, reviewable script instead. Bridging that gap between your Python codebase and their strict deployment process is handled by offline migrations and SQL generation. Normally, Alembic connects to a live database and executes schema changes directly over that connection. But when you need to hand over a plain text file to a DBA team, you use offline mode. By appending the --SQL flag to your upgrade or downgrade commands in the terminal, Alembic completely changes its execution behavior. Instead of running the statements against a database engine, it renders them as a continuous string of standard SQL and dumps them directly to standard output. You can easily redirect this terminal output into a text file. This dual behavior is not magic, it is explicitly defined in your project environment file, typically named env.py. If you look inside that file, you will find two distinct routing functions. The first is run migrations online. This function creates a live database engine, binds an active connection to the Alembic context, and runs your migration scripts step by step. The second function is run migrations offline, and this is where the translation happens. When you pass the SQL flag, Alembic detects the flag and triggers this offline function instead. It configures the context using only a database URL. No network connection is made, and no engine is instantiated. It then takes your Python migration structures and generates the exact create, alter, or drop statements, wraps them in standard begin and commit transaction blocks, and formats everything for your specific database dialect. Here is the key insight. Because offline mode never actually connects to the database, your migration scripts cannot rely on active database state. You cannot execute a select statement inside an offline migration to check if a row exists, and you cannot inspect the current state of a table before making a change. If your Python code expects a cursor to return data to decide what schema change to make, the offline generation will fail. The script must be purely declarative. It simply tells Alembic what structures to generate. Consider a developer finishing a local feature branch. They have run the migrations locally in online mode to verify everything works against their testing database. For the production release, they run the upgrade command with a specific start revision and end revision, add the SQL flag, and route the output to a text file. The result is a clean, sequential SQL script. The developer hands this file over to the DBA team. The DBAs can read it, verify it against their strict security policies, and apply it during the maintenance window using standard database administration tools. You also have control over how this offline output is generated. Inside the Run Migrations Offline function, the context configure call accepts parameters that tweak the rendered SQL. A common requirement is converting variables into literal values. By enabling literal binds in the configuration, you ensure that any data inserted during the migration includes the actual values directly in the SQL string, rather than outputting generic parameter markers. This ensures the output is a fully self-contained script ready for execution. The true value of offline generation is predictability. It turns dynamic Python state changes into static, auditable SQL that any deployment pipeline or security team can verify before a single table is modified. That is all for this one. Thanks for listening and keep building.